All right, recording has started. So I'll start with you first. Let's open the lecture so we can start answering the assignment. Last lecture we were talking about, or we were discussing, was 05, the classes. All right. There are some additional things I will discuss with you today. Also, so I'll add a new slide which includes the assignment. This is the assignment. Write code for the following. Define an object with the name student. That means I want to define an object with the name student. So all what I'll do when I say define an object, that means you need to define a class. I close this one. So here I'll define a class, and usually the class definition comes before the main function, and I'll call it student. All right. Then, of course, you know this. Just to avoid forgetting the semicolon, put it from the beginning. All right. Now, what's required from this? Let's see. The object has ID, name, and specialization as private attributes. So I'll start, of course, as I told you, you don't need to write start private, but it's a good idea just to remind yourself to write private integer ID. I don't want to know why some of you have selected integer name. Okay, and string specialization. All right, this is error because S. All right, so let's run it. Okay, no errors. Everything is all right. Next. Write a suitable mutator. What's the mutator? The mutator, as we defined it in the last lecture, is a public method that can change the contents of or change the values of the private elements. So I will define, for example, void set name of string n. All right. Here, of course, you can go down and just to save space, I'll write it here. So here, what we'll do is name equal n, semicolon, and that's it. All right. All these are mutators, set ID. Why? Because ID, name, and specializations are private, so it's not possible to access them from outside the code or the class itself. So set ID of integer, ID small letter, okay, to differentiate it. So here ID equal ID, semicolon, and that's it. As I told you, you can use this notation or you can make it like this. It's up to you. But here I'm trying to save some space, so I'm doing it like this. Okay. Another mutator, void set. Specialization. I'll just make it shorter. SPIC or SPEC. Set specialization of string SP. Here also, I'll put specialization equals to SP and semicolon. Don't forget the semicolon, and that's it. These are mutators. Now I want to define the accessors, right? We said we have mutator to change the values and accessor to read the values. So I'll define string name. For example, as we have said, we have get. Okay, here all what we want to do is to return the name. That's it. Okay, string. Why string? Because the name is a string, so I'm returning the name, so I'm returning a string. Get ID, not ID, specialization. All right, here return SPEC. Okay. And semicolon, don't forget it. The last accessor is integer get ID. Why integer? Because the ID is of type integer. Return ID. Semicolon. So here I've created all the mutators, all right, which change the values of the private. But here also I forgot something. Here all these should be public, right? Otherwise I will not be able to access them. They will be considered as private. So set name, etc. Now in the main function, let's try something. Let's define student st1. All right. Of course, till now I don't have the constructor. We didn't try the constructor yet. So st1 dot set name of XYZ. I don't want to use a specific name. All right. And cout. Now, this is the mutator, right? This is the mutator, and it doesn't return any value because it's void. Now, if I want to read the values, I will use get. So cout get, or I will define a string s1 equal st1, or I don't want you to get confused. ss equals st1 dot get name. All right, and then cout. Let's see, execute it as C. All right, I have error here because there's no semicolon here, and yeah, let's see. Perfect. So here, as you can see, I got the name. Okay, why? Because I here use a set name. Now, if I change the name, for example, to Muhammad, all right, it will be changed also to Muhammad because this has changed the private value or private variable name using the mutator. Then I read it using the accessor. Now, what if I didn't change this or I didn't give values? Let's try get ID. What do you think? Get ID. All right. Not string here, integer. See, 640. Why 640? Of course, this is meaningless because this is what the contents of the memory, okay, at that time. So if I, for example, get SPC, get specialization, string, get specialization. Also, I'll get rubbish, I guess. Yeah, I got empty because we didn't give any value. But here, if I use this st1 dot set specialization of, let's say, MIS, then when I printed it, I'm expecting to get MIS. Okay, I have error here because I didn't put the semicolon. All right, so yeah, I got the MIS. So now you have this class of type student. I'll just move it to the presentation so we can discuss in more details. I just want to keep the format, that's why I'm using this one. All right, so, okay. I print it here, and I'll take it again, move it to the assignment. Okay, so I'll copy it, and this is the answer now, the final answer, and we'll have a little bit more explanation. Okay, so if you can see, we defined the class student, all right, and these are private. That's why I added the keyword here, public, to show that these are public. All right, so this ID, name, and specialization cannot be accessed, from outside the class, right? Why? Because they are private. So in order to access them, I need to create functions which are called as mutators. So mutators, the first one, this one, set name, will change the value of the name, or to give value to the local private variable name, set ID, and set specialization. All right. The other thing is, if you can see, all of them are void. Why void? Because here I'm passing arguments. So when I called this, for example, st1.setName of Muhammad, so it will call this function. It will give or put the name that I've sent to n, and n will be equal to or name equal to n, and that means I change the value. All right. Here the other thing is the accessors. The accessors are really important because you need to focus on the type of the accessor itself, of the function, of the member function. Why these are string? Because I'm returning the name and specialization, and the name and the specialization are both are strings, right? Why this is integer? Because I'm returning the ID, which is of type integer. All right, so you have to focus on the type of the accessors and the types of mutators. The type of mutators always are void. All right, and of course here inside the arguments, like if I write here void set name of, here you have to focus on the type. Here the name is of type string, and then inside our write name equals to n. Of course, a name is a string. That's why I need to pass a string variable to it. As I told you, this is the better way to write it, but to save the space, I had to write it like this. Okay. Do you have any questions about the assignment that I've given to you? Is there anything vague or not clear, or you want to ask about it? Please feel free to ask. All right. Since you don't have questions, then let's go again to the last discussion, which was the accessor and mutator, and I showed you here in the accessor and mutator. You notice something new. That's why I've created new slides for this, which are defining a member function outside the class. What does that mean? Sometimes you don't write everything inside the class. If you can see this class, okay, I have only the prototype of the function, integer get num, void set number of constant integer number, and I don't have the definition of the function, right? Because this is a function, but I don't have the definition. So sometimes you can define the function outside the class, but with one condition, you have to use this naming. For example, here you define integer get number of. So if you want to define it, you have to use integer. You outside, of course, outside the class. If you can see here, the class has ended here. Okay, integer, the class name, num, then double colons. This, all right. Then the name of the function, get num. All right, and you can write the function. Okay, these are used only outside the, if you define the function or use it outside the class. All right, return n. If you can see here, I've written this. When you define a member function outside the class, one, declare it inside the class. You have to declare it inside the class. And two, use class name, okay, double colons, then function name to define it. So let's try it practically. The other way to write it is to write it like this. If you can see here, this definition inside, this is inside the class, right? So when I write here, integer get number, then I open these braces and return n. Now suppose I want to change this to define the function outside the class. Please just pay attention now and see what I'll do. First of all, I will remove all this. Okay? And I'll add semicolon here. Why? Because this is just a definition. Then I'll go to the end and write integer. Okay? The name of the class, exactly the same, colon, another colon, and the name of the function. And I will write the function, which is return n. All right. Here I don't have semicolon, no semicolon here, but I have here semicolon. Now, if I ask you to change this one also, what will you do? You'll take this part, okay? Of course, you can copy it or cut it, but here I'll remove it. Then I'll put semicolon. I'll go to the end, okay? Because I don't have space here, consider that I'm working here. I'll go to the end and write void class name, colon, another colon, then function name of integer n, for example, and then n1, and then n equals n1 and semicolon, and that's it. All right. Again, I wanted to focus that how to convert the or how to move the function definition from inside the class to outside the class. I think it's clear now. So both are correct, and this is the answer of the question of the assignment. I'll share the presentation with you. Again, also it's shared already, but I will update it. So I'll go to File. I replaced the old one with the new one. Okay, so this is number 5. Do you have any questions? Anything before proceeding with or continuing with the rest of the discussion? Okay. Now also, after we understood all the principles of the classes, we can now move a little bit forward for more techniques. So this is lecture number 6. I will share it after we discuss it, which will discuss about inheritance and super class and derived class and so on. So the main idea is sometimes, okay, for example, let's discuss this scenario. I have in the college, I have students and I have employees and I have faculty members. All right. If I came and find, for example, let's start with a student. What are the main features or attributes of the student? I will think of ID, name, phone number, right? Address, specialization. Okay. How about employees? Employees also, they have ID, they have names, they have phone numbers, and they have addresses, but they have salaries, for example. All right. Faculty members, they have IDs, they have names, they have phone, they have addresses, they have salaries, and also they have courses or courses to taught. That's what's call it. Okay, courses, specialization, all right, etc. So in this case, if you can see, if I define 3 different objects or classes, then I have to repeat some of the attributes continuously, like this one, the name, the phone number, all right, the address, okay? Here, the same thing. So there will be some kind of redundancy of the definition or of the, but what's the better way to do this? I can take all these common things and put it in one class, like I call it person. Okay, the person who has ID, okay, name, phone number, and address. Okay, and remove these from, okay, all the persons. All right, I mean all other individuals. Okay, so In this case, I will create something called superclass called person, and I'll define subclasses called student, another subclass called employee, another subclass called faculty member. These subclasses inherit, by the way, inheritance means in Arabic وراثة, يعني ترث المعلومات هذه. So they will inherit all these things from the person, okay, but they will add something else, like here for the student, specialization, GPA, any other things. For the employee, salaries, salary, attendance, etc. For the faculty member, salary, course, specialization, etc. So this is the idea of having the inheritance. I have superclass, all right, and subclasses. Of course, how to do this? In programming, I will write like class, okay, student, colon, inherits, this means inherits person, okay? It will have everything that the person have, all right? Of course, the same thing here. If I create class employee, employee inherits person, all right? The same thing. So I think that the idea of inheritance is sort of clear now. So let's discuss it. When derive a subclass from original class, the derived class or subclass, sometimes it's called derived class or subclass or child class, will inherit all the attributes and methods from the original class, which is also known as superclass or parent class. All right, so I have, as I told you, the person class. This is just an example, and I defined a student class from person. Then the student will take all the attributes, all the features from the person. In addition, it can add some other attributes and features. All right, methods. Okay. In the following example, the class circle enhances the coordinate x and y, and the methods of in addition, it has its own method. All right, so let's see here. I have point. Point, you know, the class point is only x and y, right? So if I define a class called point, what do I want to? Okay, what are the attributes that I need? Class point. I need, of course, private. I'll consider them private. Why private? Because I want to keep them not accessible by everybody. I want to keep them private, and I can access them through mutators and accessors. All right, so integer x and integer y. That's it. So this is what, if you, as you can see here, I define the class point. I have private x and y only. What else do we have? I have public, which is the point integer. This is the constructor. By the way, we didn't create the constructor in the previous example or the assignment, so it's okay. You can do it. Here is the constructor. Okay, it has the same name as the class, and it initializes the values. So a constructor of integer x1 and y1, x equal x1, y equal y1. So this is a constructor. Okay, and has to be public. All right, here I have get x and get y. which is what we call this accessor. All right, and here we have mutators, set X and set Y. All right, and we have also print, another method to print the point. So it will print the point like this, X, comma, Y, and between parentheses. So I have this point class, class. Let me just, I'll keep this. Let's write this code and see how to use it. So I'll go there. Okay, I'll just remove this. Okay, so here in the class, I'll define the class point. Okay, inside, of course, I'll private and colon integer X and Y. You can write it like this, no problems. Okay, this is at the private, and I have public. Okay. Now let's put the mutator. Okay, so void, as we said, the mutators are void. Set X of integer X1. Why not X? Because I don't want any conflict between X and X1. So here I'll put X equal X1. Easy. Void set Y of integer Y1. Y equals Y1. Done. Now these are the mutator. Let's think of the accessor integer get X of course, no, nothing here. I don't want to pass any argument. So here only I return X semicolon and integer get Y of return Y. So this is the point class. Now if I want to define here point, I can define point, capital P, point P1, all right, and I can put P1 dot set X of 4, all right, and P1 dot set Y of 7. Okay, that means I already said this, but I didn't print them. So I'll define here another method, which is print. Okay. Print all what I'll do is, of course, it's void and void. That doesn't take any arguments. Here, cout. I'll put \n, then this one, and X between brackets. Then I need a comma, right? And Y. And of course, I'll close the braces. That's it. And end line. Okay. Let's try this one. And see how it works. Okay, I have error here. Where is it? Yes, I didn't close the parentheses. Okay, so this is what we got. I'll just remove the space from here. Okay, so if I want to print the point, you know, the point should be printed like this: 4, comma, and 7. All right. So if I change this, for example, to 67 and this 71. All right, just to make sure that it works perfectly. Yeah, it works perfectly. So what I did here is just I moved the, or I changed the values of X and Y, put them to 67 and 71, and I print them. All right. Now, if I want to get the value of X, I just say, for example, of course, they are integer. Integer A equals P1 dot get X, right? And if I want to print it, C out A, okay? See, I'll get 67. I got the value of X, which is 67. If I want to get Y, then also get Y, and I run it, got 71. Till now, we didn't do anything new. We just created a class, a new class of type, a new class, a new object called point. Now, if I want to inherit or create a subclass, which is, in this case, we call it circle, all right, what I'll do, I'll go there to the discussion and show you what to do. First, you need to use class keyword, then the name of the new class, then colon, the name of the super class. Okay, so that means the circle will inherit everything. Why? Because actually the circle is like this, okay, and it has center. It has X and Y. So instead of defining a new X and Y, I can consider this as point and add the radius as another attribute. So what I'll do here, public double radius. See the constructor here. We didn't try the constructor there, but here the constructor is very important to focus. First of all, I have point constructor. All right, here I have also circle constructor. I'll add this column. That means I'll pass X and Y to the point constructor, and I only need to define or initialize R. I'll go back to there because we didn't try the constructor here in the point. Okay. Now, if I want to write the constructor, I will write point, same exactly like integer x1, the name exactly like the name of the class, integer y1. All right. Here in this, I will just put x equal x1 semicolon and y equals y1 semicolon, and I'll close the parentheses. So this is the constructor. All right. Now again, just to, this is a mutator. Okay, this is another mutator. This or these are mutators. All right. These are accessors. This is another accessor, and this is a constructor. Now, finally, the point class is ready now. I will define now. I'll show you how to do it. Class circle colon inherits point. All right. And of course, as I told you, you need to do it like this. Now inside, I'll start with private. Which is integer, or double. It's better to have it double because I want to find the area and other things. Double R. then public. Now the constructor. The constructor is, in this case, circle of integer x in x1, okay, integer y1, and double r. Of course, here, since I inherit things from the point, I have to use the constructor of the point, okay, which is of x1. See here, point of xy here. I use x1, it's okay, and y1. So here I will continue with this. Okay, x1 comma y1, and of course r equals r1. What's r1? I will change this to r1. By the way, I will repeat this again next lecture. I want you to read it, and I will repeat it. Okay, now here, instead of having this point, I will define circle, right? So C, or here C equals circle of 7, 8, and 9. All right, that means the center, or the xy, x is 7, y is 8, and the radius is 9. Here, if I want to use C dot, by the way, now I can use all the functions here. Get x, set x, whatever in the point, I can use them in the circle. So get x, okay. I'll try it, C out. Okay. I have error here. All right. I have error also. Get x. Not error. Point is not an accessible base. All right. You know, just this time I will put public here, and I'll explain to you. Don't worry. Okay. See now. 7. I used all the functions that are the methods that are available in the original class. All right. I don't want to lose this code that we've written already. I will share it with you now, and we'll get back to it soon and rediscuss it again. I want you to read it, please. I'll share this with you now. Okay. Why it's like this? 1 second, I'll try to sort this out. No. All right, so this is the code. Although it's small, don't worry, but you can use it. You can copy it and paste it if you want. Okay. Yeah, this is the code, and we'll continue next lecture. Inshallah, we'll finish everything, and we will discuss whatever concern that you have. All right. Any questions? Okay. If you don't have any question, then thank you very much. I'll see you next lecture. Just take care and try to read it, please, carefully. And if you have any questions, we'll discuss it later. All right. Thank you very much. You can leave now. Please do.